All right, so today we're going to keep looking at exponential functions. Remember that you do have a test on Thursday, okay? So be sure you know what you're doing on these papers. Today, students will be able to write equations for linear inequalities. No, this is wrong. We're actually looking at regression of exponential functions. There we go. Predict results of exponential functions. Okay, so an exponential function, remember this is what you start with. This is how you're growing and how long it takes to grow. Okay, an exponential parent function is e to the x power. It looks like that. Exponential growth, if you read it like a book, it's going up. Exponential decay, read it like a book, it's going down. Compound interest, A is the amount after t years, P is the principal value, R is the interest rate, and T is the number of years. Okay, so let's go to your worksheet. Okay, so number 1, the very top part. It says the table gives the approximate values of diamonds of the same quality. Find an exponential model for the data. Use the model to estimate the weight of the diamond worth $2,325. So first thing, this is telling you the steps you need to do to solve this problem, okay? First thing, create a graph, okay? So that's what we're going to do. We're going to label this graph. I'm going to say that the graph, the bottom I'm going to say is going up by 1/2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? And then this side I'm going to say is going up by, I don't know, 150. Okay, so this will be 300, 600, 900. Okay, so I went ahead and labeled those off camera. So you can label them yourself if you need to. Okay, so every little thing is going up by 150. Everyone's going up by 0.5 here. Okay, so create the graph. So let's take this table and let's graph it. So we have 0.5 and 920. So we go to 0.5 and go up to 920, which would be about right here. Okay. Then we have 1 and 1160. So we go to 1 and find 1160. It's going to be like right here. 2, 1580. So 2, and we find 1580, which will be like right here. Okay. 3 and 2150. So we go to 3, find 2150, which is like right here. Okay, and 4, 2900. So we go up to almost 3000 right here. Okay, so when you connect the dots, they go like this. Okay, which is an exponential growth, right? Okay, so plot the points on the graph, enter the data into your calculator, use exponential regression to find the exponential equation of best fit. So we plotted them on the graph. Now we want to find out what is the equation, okay? So go to Stat, Edit, type in your table. So we have 0.5, 1, 2, 3, 4, and that's it. And then we go over here, 920, 1160, 1580, 2150, 2900. Okay, so now you go over to Stat, over to Calc, but we're looking for the one that says exponential regression. Where is it? Exponential regression. That's what we're looking for. So go down. There it is. 0. Okay. Hit enter. Enter again. And there it is. So we have this number here. That's A. And this number is B. So we have, I'm going to round up. That's a 0.9. So I'm going to make this 815. And I'm going to make this 1.3, round that up, 8. 1.38. So we have y equals 815 times 1.38 to the power of x. That's our equation. Okay, that's our line of best fit. What's r squared? Well, remember, to find r squared, we have to turn diagnostic on by going to second, catalog, go down to D, diagnostic on. Enter. Now we do it again. Stat, over to calc, and it was 0, right? Enter. R squared is 0.996, right? So 0.996. So is this a strong correlation? Yes, because it's close to 1. So it's very strong correlation. Now, estimate the weight of a diamond worth $2,325. Okay? So we're estimating the weight. So let's go to $2,325. $2,325. I would say it's somewhere like right here. Now we're estimating the weight. So go down. Okay? I would say it's between 3 and 4. Okay? Between 3 and 4. Estimate the cost of a 13-carat diamond. Of a 13-carat diamond. Okay, so 13 is going to be way over here. Remember that this is x, so we can type in this equation with a 13 right here. So we have 815 times 1.38 to the power of, that x needs to be 13, right? Enter. Okay, so the estimated cost, I'm going to just use this part, I'm not going to use any decimals, so I'll round that up to 2, is 53652. Okay, that's the estimated cost of a 13-carat diamond. Okay, let's scroll down. Next problem. Use exponential regression to find a function that models this data. When will the number of bacteria reach 2,000? Okay, so number of bacteria. Remember that this is x and this is y. It's always important for you to know what's x and what's y. That helps a lot. So let's find the equation of best fit by typing into stat. So stat, edit. Let's clear this. Okay, so we're going to type in the table. So we have 0, 1, 2, 3, 4, 5. Now we're going to type in the bottom part. 200, 248, whoops, 312, 390, 489, and 610. Now stat, over to calc. Remember we want exponential regression. So you go down to 0. Enter. So our equation of best fit, I'm going to just use the 199. That's a 2, so it stays 199. And then I'm going to do 1.25. Just stays 1.25. So the equation is y equals 199 times 1.25 to the power of x. So predict how many minutes does it take for the bacteria to reach 2,000? So what's our x to reach 2,000? Okay, what's our x to reach 2,000? Let's try typing this into y equals. Let's see how that works. So 199 times 1.25 to the power of x. Let's go to our table. We're trying to see when y is 2,000. Okay, when y is 2,000. So let's scroll down. There's 900. When y is 2,000, what numbers is that between? It's going to be somewhere between 10 and 11, right? Between 10 and 11. Now when they ask you this question, more than likely it's going to be multiple choice, so you'll be able to very clearly see when it will be between there, okay? Alright, so flip your paper over. Okay, so you're going to do these on your own, okay? Don't forget to submit them online. I want you to look at a few things, like where it says less than 40 degrees, okay? It's going to be less than 40 degrees as soon as it hits 40 degrees. No. On this one, make sure it's to 2 decimal places. Okay. And I want to show you this down here. Anytime it's dealing with years, 1970 is when it started. So that's at 0 years. How many years later is 1980? It's 10 years after 1970. 90 is 20 years later. 2000 is 30 years later. Okay, so that's what you're going to be looking at here. You're not going to type these into stat. You're going to type in these into stat. Okay? All right, be sure to submit your answers online. Let me know if you need any help. Good luck, guys.